Hello, everyone. This is Sebastian Traeger, Managing Director at reliability.com, and we're back with another episode of Reliability 4.0. As always, we're on a mission to make the world a more reliable place. And today we are joined by Dheeraj Narang. We're glad to have you, Dheeraj. Thank you for joining us today. And we're going to talk a lot today about Corrosion Management 4.0. Dheeraj is an expert at that. He's been getting a PhD at Harrisburg University in the topic. And we're going to have a more in-depth conversation specifically about what it means to boost reliability and enable smart asset integrity strategies in plants. Dheeraj, thank you for joining us. We're glad to have you today.
Good morning, Sebastian. Thank you so much for having me. I'm excited.
Great. Well, so you're getting a PhD at Harrisburg University. How did you end up there, and why did you decide to get a PhD?
It began with, my inclination towards doing like smart asset management and, build on top of my mechanical engineering acumen. So I was looking for a school where, offers a program in systems engineering and management that could, blend my technical acumen and also like help me build machine learning, IoT, and big data management competency. So that's how I end up there. So it's an executive format PhD, so I can also like work, alongside my job. So that worked out really well. Yeah,
that's great. And so how did you like living in Pennsylvania? How long were you there?
I was in Houston, Texas. So since it's an executive PhD, I travel three, 4 times a semester for a symposium and, in-class laboratory sessions. So that's how, it works out. Yeah.
Great. Well, before we dive into our topic at hand today, just love to know a little bit about your story. How did you end up becoming a reliability engineer, and how did you end up kind of where you are?
Yeah, so I began my career with Larsen and Toubro right after my undergrad from Maharaja Sayajirao University back in India. And I was doing like construction management, project management, regular, static equipment engineering. Then I moved to US and I did my master's in mechanical engineering again with a focus of advanced thermodynamics and material behavior. And I ended up with, a consulting company called PACT. And then that's where, my operational excellence / asset management in an operating world, began. So ever since then, I have been, doing reliability engineering for, I think, more than 9 energy companies around the world, 3 different continents. I have been on, conference committees as organizer and, second chair. So it's been a fun journey.
That's great. That's really neat to hear. And I always like to ask this before we dive in again is what do you like to do outside of work? What hobbies, interests that you have?
A favorite hobby is Indian ancient astrology. So I also like monitor, the speed of the planets going around in the solar system and how that, affects your life events. And I lean towards a more analytical part of it. So, it's all about, how do you split a sign, what degrees, and what happens when a particular constellation falls into a particular house and all those stuff. That's my number one. Apart from that, I also play a couple of sports, but those are like recreationals.
So fascinating. So I want to drill down on that just because I don't know a lot about it. Are you getting data on stars, or are you actually looking at them and recording, or how does that work?
So it's based on the, like progeny. So when a child is born, depending on the place and time and date where, the kid is born, there is a snapshot of, planets in their chart with their speeds and, like motions and stuff. And that's where, it all begins. So I try to, map that karmic manifestation with their, lineage. And it's very fascinating. It's like, no matter how deep you go, there is always more to go.
That is fascinating. Well, thanks for sharing about that. That's probably a topic I'm gonna try to learn a little bit more about because I just know nothing about it. So, well, good stuff. Well, today we're not going to talk about that anymore, but we are going to talk about Corrosion Management 4.0. And just for our audience, why don't you go ahead and explain, when you say Corrosion Management 4.0, what exactly do you mean by that, and why should we care?
Yeah, that's a very good question. So corrosion management. So if you look at the process plant industry, such as oil and gas, petrochemicals, and anything that has, processing of the fluid, there is an interaction between the fluid and the metal, right? In an equipment, in a piping, in a, pressure safe safety valve, and all types of pipe fitting. So one has to learn what kind of corrosion/damage mechanism the asset is going to experience. Without that, there are no bases, so you won't have any inspection plans. I mean, you can still have an inspection plan, but it is going to inform way better that what kind of a damage you need to anticipate in the actual process, and then you can build your reliability engineering plans based on that. Now, when I say corrosion management 4.0, it means that, driving the maximum value out of your corrosion management program. So first would be regulatory compliance. It can also help you, comply with OSHA PSM or EPA RMP regulations in the US. It can also help you maintain the integrity of the equipment and then eventually the reliability of the equipment. Yeah.
Okay. And walk us through what either tools you use or what techniques you use to actually bring this about. So what are you applying in order to get that optimization?
Yep, sure. So corrosion management begins with, like a fundamental step of collecting data. So you would need process engineering data, like what's going on with the fluid composition, operating parameters. Then you would also need inspection histories. Was there any damage found in the asset? And then you would also need the fabrication and QA/QC history of that particular asset. Now, when you integrate that, then a corrosion specialist has to go and check all the damage mechanisms. They call it credible to that asset, because sometimes what happens is there are generic documents available that defines a corrosion mechanism for a particular type of plant, but that may not apply to your plant because the conditions could be different. So once you define your damage mechanisms, then there are industry available tools to, build your inspection plans around it. It could be either traditional, it could also be a risk-based inspection plans where you assess the risk, have your probability scales and consequence scales. And that's when it falls into, core domain of reliability engineering. So the better the tool you have, the better you're going to have your risk assessment, and the better you can forecast your risk and mitigate it on time.
Okay. So you're leveraging data in systems. So if I don't have data, and that's step one, right? It's like put in place good data capture mechanisms. And then presumably, and I guess this is a big question I have, is how do you make sure that there's integrity to that data, that it's good, true, et cetera?
That's a big issue, and that's an industry-wide issue, to be honest, in all processing plant industries across the globe. So for data, the better and best quality of your inspection data management systems, as it relates to damage mechanism and in-process defects, the better your corrosion management program will be, and eventually the risk-based inspection plans and reliability improvement. Now there could be a case where it's a new plant and you don't have the data. In that case, the team can benchmark against industry available data, or if it's a big company with a sister plants, they can leverage those and have like initial reliability engineering plans and initial damage mechanisms. And as they operate their own plant and find out what's going on, they can either reduce or increase the risk depending on how much the defects or damage rate they found. And there are industry available tools as well that could immediately give you a benchmark risk. But there is always a caveat. There should be a specialist involved so that you don't want to inspect too much, hoping that a damage mechanism is active when it is not. Right. So there are some caveats to it as well.
So that's interesting. When you say there's industry tools regarding data and risk for benchmarking, does that other companies supply that? Is that publicly available? How do you get that data?
Very, very good question. So I'll give an example. Like American Petroleum Institute has API recommended practice RP 581. Now that's a risk-based inspection method. It has a fully quantitative what kind of a damage mechanism would apply, what kind of a temperature range, and what kind of a metal. It's so precise. It's a big document, 800 pages. And there are industry available tools that embed those API 581 technology into their tool, and then they enhance it and give you a customization option for your particular plant. So one can begin there, to have like industry accepted programs. Now, some process plants are so niche, so unique that, you will only have like, say out of 76 active damage mechanisms in API 581, you would only have like 12 applicable to your, facility. So in that case, there is an optimization step in the initial decision making, and that's where the subject matter expertise will come into picture.
That's good. That's good. So we've got the data. We want to do something about it. We're calling this obviously Corrosion Management 4.0. How are we leveraging, machine learning, AI, whatever you want to call it, big data? How are we leveraging that in order to predict outcomes, predict changes? How's that happening?
Sure. So one problem, I routinely ran into in my own career is, when you have a risk-based inspection screening, say you have your damage mechanisms, corrosion mechanisms defined, and then you do a screening. So the first step is, say, for example, a process plant has 1,500 equipment, pressure vessels. That's a big number. Now you can't do a detailed RBI assessment on each one of them. So you would have a screening step. Now, what I observed is, depending on the competency of the RBI facilitator / subject matter expert, the screening results were varying. So that's where, machine learning can come into picture. So as part of, one of my PhD course, I developed a machine learning model, and it's a supervised machine learning model to have, correct, RBI screening. And that actually, alleviated a lot of biases in regards to the RBI SME when it comes to, screening the equipment. So that's one specific example where machine learning could really play a big role into it. Yeah.
That's good. That's good. And how are you actually executing this? Is there a software platform you're using? Is there one that you recommend to folks? Is it Excel? How are you, crunching the data and actually determining, steps to take?
In regards to developing a machine learning model, I think what I did is I used Kaggle and I developed a base model in a Jupyter notebook using Python. And there are like MATLAB, and there are plenty of sklearn, plenty of Python libraries which will have supervised machine learning functions. So you can call upon those, optimize it, use an algorithm of your choice, and do stuff. Once you have the base machine learning model, one can integrate that with an existing inspection data management system. We discussed that in the beginning, that a site needs to have a very good, IDMS. And it's also sometimes known as CMMS, computerized maintenance management system. Depending on the functionality and scope of both these software, sometimes this could be distinct in a facility, sometimes it could be one. So one can map that machine learning model into those IDMS and have the screening take place. It could also be a case that there are industry available tools which already have a machine learning screening embedded nowadays. Like for example, NTI is working on that. GAPM, the Meridian, they also have now a screening tool which can do a basic supervised machine learning modeling to do a screening for you. Yep.
That's good. So talk to us about results. Obviously, we want to be thoughtful about our approaches, but what improvements can you get from when you think about 4.0 as opposed to 3.0 or 2.0? What do you feel like the benefits are going to end up being?
When we say corrosion management 4.0 as it relates to reliability engineering 4.0, I would say for process plant industries, one can have a program that does all three things. The first one would be regulatory compliance. So you can have scenarios like, okay, if this is a damage mechanism in this particular vessel, if it leaks, what happens? And then you have a consequence assessment and the risk assessment, and what are we doing, what the plant is doing to mitigate those risks. One can have that. So that's number one checkbox, regulatory compliance. Otherwise, what happens is without a integrated corrosion management 4.0, one site has to do a process hazard analysis on its own, which could be not integrated with the reliability engineering programs. So you're sort of doing the things twice. See, and second benefit is, improve integrity management. If you have good data, you have good, corrosion mechanisms defined, you can better have your inspection plans optimized. The asset which have less credible or less severe corrosion management, you can reduce the inspection budget for those. And the asset which have higher risk or more severe damage mechanisms, you can have more inspections, more frequent, improved technology, and all those things to have your integrity maintained. And the third step is reliability improvement, right? I mean, you want your asset to do what you want it to do. So if you take care of 1 and 2, the 3 is going to automatically fall into place.
Good. Well, even that second step, just optimizing inspection plans, it sounds so obvious. Some you want to reduce the inspections, others you want to increase the inspections. Yeah. That's just such an obvious, just saying it makes sense, right? You don't want to apply it. And so I can see how just that one step is going to potentially dramatically improve performance.
Yep, I agree. Inspection budgets could, for a mid-sized refinery could run into millions of dollars a year. So if you're spending that kind of money, you might want to spend where the highest risk are.
Yeah, absolutely. So our company, of course, does root cause analysis. So I always like to ask folks about, how does root cause analysis play into this? Is there an intersection? How'd that work?
There is actually. So to build, an effective reliability engineering plans, one has to look at the past inspection history as well. So when we say inspection history, it also includes operational history and any incidents or failure that has happened. So all the RCFA the data feeds into the corrosion management 4.0 as a very big input. And on top of that, if there is an incident or if there is a loss of containment, incident, it could be a minor one, things got contained, but then you need to investigate, right? So the first step of RCFA, or people call it RCA, is again damage mechanisms, like what is happening inside, what is happening to your metal, right? So
Right.
it's a very big chunk of it. Yep.
And is the data that you're using, have you seen ways to get that data into an RCA, RCFA in order to solve those problems?
You mean data into an RCA tool, like a?
I'm actually asking, so some of the data that you talked about being able to pull in order to analyze, are you also able to pull that into doing an RCA? Is that same data also useful? The model that you trained and some of that?
Yeah. So the entire IDMS, right, inspection data management system, it houses histories of past incidents as well. So one has to know what has happened to the asset, how it ran over the last 5-10 years, right, and then what incident happened when. So all of that directly feeds into an RCA. RCA is a big chunk. So if you have an RCA report done recently and it says these are the damage mechanisms, when you do a reliability engineering planning based on that RCA result, your risk could go up. And then you have to mitigate that, and you have to inspect more or either change the metallurgy, upgrade the metallurgy in the next scheduled shutdown. All of these things are driven by RCA. Yep.
It's good. It's good. Well, listen, it's been a great conversation. I do want to wrap up, but I do have a question I always like to ask, kind of a one final word. So, part of the point of this podcast is just allowing folks to teach others. So what is kind of one thing from your field of expertise? Obviously, you've been sharing a lot about that, but if you were kind of going to boil it down, what's one thing, nugget, wisdom you'd want to pass on that you don't necessarily think people are spending enough time thinking about?
I would say have a corrosion engineer in team when you do a reliability engineering planning or when you do a RCA, because sometimes most facilities I've come across, they rely on process engineers to identify the damages. Now they can also have a bit of metallurgical background, but sometimes they don't. So I would say the main suggestion which I've seen lacking in my career, that you should have a corrosion specialist on your team. Like for example, I am an AMPP and NACE corrosion technologist, and to study that and pass that exam, I had to study like for 18 months. So it's a very tough exam. It's like an intersection of process engineering, metallurgy, and then you have different corrosion mitigation techs as well that you have to learn, like cathodic protection is one for underground piping and so on. So I think it would really help. That's my suggestion.
Having a corrosion specialist on the team.
Yes.
I love that, how specific that feedback is. That's, I think, very actionable and very helpful. Well, it's been great having you. This is Dheeraj again, has been joining us. Thank you, Dheeraj, for your time. Dheeraj is, of course, getting a PhD at Harrisburg University. He's a corrosion engineering specialist. So we're thrilled to have you. And to all the listeners out there, again, this podcast is really about helping engineers and anyone really take steps to not just think about ideas, but think practically and how to use technology in order to solve problems. Of course, if you're looking for anything related to RCAs, whether that's training or resources, materials, check out reliability.com. If your company wants to use software to help them, we have our software, easyrca.com. We'd love for you to check out. Well, that's all we have for today. Thank you for joining us, and let's together work towards making the world a more reliable place. Thank you, and we'll see you on the next episode. Take care.